Welcome everyone to the Fairblock demo on private decryption with general conditions using Rust smart contracts within the Fairblock blockchain FairyRing, which is in testnet. This tutorial is a follow-up to the basic tutorial on preparing, encrypting, and decrypting transactions within the FairyRing network. If you haven't checked out that tutorial, please do so. It's in the docs. And my name is Hash Titan. Y'all can call me Hash. I'm the DevRel contributing to the ecosystem. And with that, let's get going. So you will find today's demo repo called FairyRing under the Fairblock GitHub organization. We're going to be using the feature branch called contracts. This one here just needs to be merged into it. And the feature branch contracts will have a README detailing the actual steps involved and some main gotchas that are key to recognize, because at the end of the day, you're going to be using this tutorial as a reference guide to create your own confidential app or cApp on top of FairyRing and using some key transaction flow details. So the main gotcha that we're going to try to focus on, right, is just like the basic concepts that will be involved in the transaction flow covered today for a Rust smart contract on FairyRing that leverages the dynamic confidential computing power innately within the FairyRing network. And also we do it using a bash script. So in the previous tutorial, it was all about preparing, encrypting, and decrypting transactions, but interacting directly with the FairyRing chain itself. Whereas in this case, as mentioned, we're going to be deploying a Rust contract that will then be interacting with FairyRing itself. And so our bash script is going to be interacting with that Rust contract. And so with today's demo, I won't go step by step through everything. It's detailed as mentioned throughout this README, and we may provide even more detailed videos later on. But for today, I just simply wanted to walk through the overall transaction flow to anticipate for contracts like this and to use that as a guideline when you're creating a cApp that may actually use this transaction flow pattern. Okay. And as well, just show you that it obviously works and to basically give you the next steps to take to work with our ecosystem. Cool. So essentially, as a kind of like summary or refreshment, so last time we were interacting directly with the FairyRing network using a bash script. And as mentioned before, the CLI commands and whatnot are prepared and available for typically like front-end developers in another repo within the Fairblock GitHub organization. And for today, though, we're going to focus on two main concepts within the Rust contract, like template, let's call it. Essentially, one, so last time we focused on using conditions that were block height based only. That is kind of like the default default condition that is used when just directly interacting with FairyRing with encrypted transactions. It'll expect the condition to be a block height within FairyRing, and it'll wait for that block height to be passed in order for the decryption key to be generated from the validators from FairyRing. But in this case, we're going to be using general conditions and specifying those general conditions within the Rust smart contract. Okay, so that's where the general condition logic lies. And then from there, within, say, it's a certain function within the Rust smart contract that is checking the conditions. So we'll connect that general condition. It could be, say, swap price, whether someone actually paid for a service or a transaction, you name it. And essentially, once those conditions are passed, right, once we set those conditions, then we basically will then request a ID connected to the respective like Rust smart contract that we're creating. And then thus, when someone calls the request ID function that we're talking about here, they'll also get they'll specify the conditions for said transaction and then get a ID, a unique ID from FairyRing that FairyRing uses to basically understand like, okay, this ID is linked to this transaction. And that's a very key thing because FairyRing will associate that ID to the encrypted transaction then that will be generated within the smart contract using FairyRing. And then from there, that kind of like association is leveraged and used throughout the smart contract accordingly. Okay, so that's like step one is talking about the concept of using general conditions. And then step two for the Rust contract in terms of the main gotchas is that this transaction flow focuses on using what we call private decryption. And essentially what we're referring to is that the decryption is carried out such that the key shares from the FairyRing validators aren't public right away. They are actually encrypted with a specific public key associated to the caller's wallet. So that's a nice segue to like the example that we're going to be talking about today, which is essentially creating a smart contract that encrypts a loot box. And for today's purposes, we'll black box the loot box concept and just simply make it a string, a fun string associated to games or whatever. And essentially, the smart contract allows a creator of said loot boxes to come along and call a function to request an ID, and then they'll set the conditions. So let's say it's payment for the said loot box, and then they'll set the ID for it, and sorry, they'll request the ID with the set conditions. So just like some payment, like 1,000 fairy tokens or what have you on the testnet. And then from there, they'll encrypt it using FairyRing. And then boom, you have your encrypted loot box as an encrypted transaction. And then afterwards, a gamer will come along and actually pay and then thus like pass the condition set for the encrypted transaction to be decrypted. They'll call a function decrypt. Again, this can be all kind of like done with a nice front end, but we're going to be obviously walking or when you look at like the repo, you'll be looking at like the direct code via bash script and the Rust contract itself, because we're all about talking about creating the Rust contract today, more so, and just seeing it work at a high level. But essentially, when the gamer calls to decrypt it, then they'll essentially get a set of encrypted key shares from the validators, and those are encrypted to that gamer's wallet that is calling that transaction to decrypt and get the decryption key. So from there, then the gamer uses the actual decryption key once it's decrypted, and then decrypts the transaction and obtains the loot box accordingly. All the stuff I just said is like outlined in like the key lessons from this demo, and furthermore through the README. But TLDR, or to nutshell everything, essentially the main focuses of today's demo, right, is to showcase a Rust contract that actually has the main gotchas for using this transaction flow, where this transaction flow is focused around like the key lessons of using general conditions within the implementation logic within the Rust smart contract itself, such that people can specify whatever conditions they want for their confidential app or cApp, which is cool. And then from there, that how those conditions are then associated to a unique ID to FairyRing, right? And from there, how a separate user can come along and actually pass the conditions, and then thus by going through the smart contract condition logic, right, when requesting the decryption key, and thus like requesting access to whatever encrypted transaction that they're talking about, and then from there in, and then from there like the user receives encrypted key shares, and thus like a uniquely encrypted key share for them. So then this like really tightens up the whole kind of like encrypted transaction flow, such that if I'm a content creator, right, I create such like the loot box, for example, I encrypt it, but I only want a one loot box with a unique password per buyer or gamer, then this allows me to ensure to have like one unique um, content or encrypted transaction for a unique gamer and their unique wallet. So it's a very powerful concept. but it can be a little tricky to wrap your head around. And on that note, right, like you might be asking, okay, well, like you gave me a loot box example, like can you talk about some more examples? Well, there are honestly endless ones. Please make sure to check out like our ideas page, like our RFP page on our ecosystem Notion doc. So there, it's like our ideas are getting live updated there, and we're happy to chat with you in our Discord, etc. But three that I'd like to touch on really briefly is like private data marketplaces for AI models. User where like user owned data is essentially provide encrypted and provided within like this is imagine someone created like an actual marketplace application or a confidential app within FairyRing where the smart contracts essentially receive the encrypted um, will basically encrypt and store the data for the AI models. And then the AI model agents, whomever comes along, and they have to pass conditions such as like trust criterion or maybe where the AI agents are located. I don't know. Or just like a payment for the data. And then from there, they can actually decrypt the data uniquely for themselves. And then another idea is like content behind conditions and or paywalls. We've kind of talked about this a little bit. Like imagine just replace loot boxes with, let's say, like your favorite crypto content creator, and then essentially when if instead of using like a Web2 subscription solution, they can instead use someone can make like a smart contract that basically encrypts the passwords to access the actual content for the user. You can call it something like Fairy Fans. I'm waiting for that to actually be made. Anyways, and then a third one that I'd like to highlight is trusted solvers for intent systems. So like intent systems are pretty nascent right now over the last few years. They're really powerful concepts, but when you want to actually work with a specific solver, typically there's like centralized risk vectors involved behind the scenes. And so a decentralized solution could look like using fairy ring confidential computing to actually encrypt the intents and have conditions on them such that only certain solvers are like whitelisted or maybe like is like something like a trust score associated to solvers such that those intents are only solved by like credible solving like solvers themselves. Cool. Okay, so we've kind of gone over like the key lessons already. I've gone over some quick concepts. So with all that, let's just jump into like the actual demo itself. Okay, so you can see here, I have the repo cloned on my local machine. And from here, we're going to simply run make devnet up. So I've already actually done that. What that's doing is spinning up a local devnet for FairyRing on your machine. And you'll have the same 5 wallets that are going to be used within this tutorial. Everyone has the same 5 wallets spun up on their local devnet. Make sure you have Docker running, of course, when you run before you run make devnet up, so that it creates a local container for all of this. Okay, and then from there, all we're doing is simply running this private decryption fairy ring tutorial bash script, and you can find it here under the root of the repo. And essentially, as mentioned before, we have like the same wallets, same addresses spun up every time for the local devnet. And all these variables are used throughout the tutorial. And essentially, right, like I'll explain them really quickly. This is always like the same deployed address for the contract that we're talking about today. So the loot box contract, for lack of a better name right now. And then the wallets 1 and 2 are the wallets being used throughout this tutorial. Wallet 1 is the one actually creating the loot box. Wallet 2 is the one accessing it and getting the decryption key. And then we have the pub key that is being used to actually encrypt. So this is from wallet 2. It's encrypting the key shares when it's requesting the decryption key. And then it's going to decrypt it with its own private wallet, right? So that's where this comes in, or private key. And this is the amount paid for the transaction as a condition. And that's about it. And essentially, as you go through it, essentially you'll see different steps. So step 1 is like wallet 1 requests an ID. You can see here the details of the bash call to the respective contract, requesting identity and stuff like that. And then furthermore, step 2 and onward is like fetching the generate ID from the contract. So that's actually still interacting. Yeah, still interacting with the contract itself. And then furthermore, registering the contract against the generated ID. So you're registering it on FairyRing. So this is actually a command directly to FairyRing. And then from there, you have encryption of the actual respective transaction. So in this case, the loot box is the One Piece is real. I hope there is One Piece fans out there watching this. Anyways, and essentially this can be done typically off chain. Sorry, yeah, typically off chain using FairyRing to carry out the encryption. Usually it's done via the front end, just behind the scenes. So the transaction is pretty seamless when a user is coming along to the app. They won't really see all of this happening. And then from there, the encrypted transaction is stored in the respective smart contract. And finally, then the second wallet, so wallet two, comes along and requests a private key share. So it's calling the Rust contract and it's calling request private key share. And it is then getting encrypted against its like respective hub key. So that's what this variable is. And then from there, the wallet two will then query the contract for the encrypted key shares. And then finally, it aggregates the key shares. Again, this can be done off chain. And then from there, it decrypts it accordingly. From there, it gets the decryption key from the aggregated key shares and then decrypts the message and obtains it. So all these steps are the steps behind the scenes. But then realistically, of course, for a user interacting with it, like let's say the gamer or the user two who's trying to get the actual decryption key and like really what they want is the loot box decrypted. They'll probably just, work with the front end for the confidential app. And a lot of these transactions that you're seeing here won't even be like prompts at all for them, and they'll just end up receiving the decrypted message or decrypted transaction, which in this case is the message. The One Piece is real. Cool. So as mentioned, this is working with a specific Rust contract. I'll touch on that in a sec, but let's just make sure it runs. So here we go. Oh, private decryption. And then in our next couple of commits here to update this demo, we're going to be taking away some of these like logs or these outputs because a lot of them are just null. But it's just going through the steps that I just walked through from this bash script. And here you can see, okay, cool. Like we did all of the preparation of the transaction, encrypted it, associated this contract, like registered it, etc. And then user two came along and then actually went ahead and obtained the encrypted key shares and then retrieved the decryption key after aggregating it and decrypting it, and then decrypted the message, and it was correct. The One Piece is real. This bash script will revert if it doesn't get the right decrypted message. And then boom, that's basically everything at work there. Cool. So now I just want to just quickly glance at the Rust contract, and we can cover that in another video in detail. But essentially, the Rust contract that I'm referring to lives under this directory path, so contract.rs. And this is the one that's being deployed every time in this tutorial. And essentially, with that bash script, right, you can find the respective transactions, or sorry, respective internal functions called through this public function execute, and essentially follow along. And we'll add more comments soon to actually help guide people through of like what to keep and how to use this contract as like a rough, interface or template. And of course, do your own due diligence and auditing for your respective contracts. But we're excited to actually build with you and work with this transaction flow that I've covered. Awesome. Okay, so with that, what are the next steps? So in general, the next steps are like always, check out the docs, check out our Discord, reach out to us, check out that CAPS idea page for sure if you want some help ideating on what to build with us. Of course, like I only went over the high level concepts today, right? Talking about using general conditions and using private decryption. And from there, I just ran the tutorial and showed you that it works. Um, it's really advised to actually go through the tutorial, go through the README, check out all the details so you have a thorough understanding. And then from there, try your hand at creating your own confidential app using this transaction flow. So use that contract, that Rust contract, contract RS as an example, and basically work with it. Feel free to reach out to us as well as our engineering team. And finally, you're able to actually contribute to the community by submitting issues to, improve our docs or quick starts, etc. And again, just reach out on Discord. Don't be a stranger. Cool. So with that, feel free as always to reach out to me. I'm at #Titan on Twitter as well as on Discord. And keep your eyes peeled for future tutorials. As mentioned before, we're accessible to not only our own chain as well as like other Cosmos chains, but we're accessible to EVM chains and more, and happily working with several different networks accordingly. So touch some grass and talk to you later.